Welcome back to the EBN course, and in this video we will be covering examples on chapter 2 on KVL, KCL, resistors, parallel series, and Wye-Delta bridges. Okay, so in this example, in this question, they ask you to obtain V1, V2, and V3. Okay, so first thing I'm going to do is I am going to redraw this because it will make a little bit more sense when it is redrawn. Okay, so your 20 and your 25 source is a 45 there, 45, and then you've got your 10 here, and then you've got a V1 here, you've got V2 here. What is wrong with my stylus? Okay, that I will assume that's a 2. And then we've got a V3 here. And then between the 10 and this one, we have a 15 source there. What is happening? 15, okay? So now we realize that, let me use the highlighter. This is one node, right? Using a different color. This is a second node, using a different color. This is a third node, and using another color. This is our fourth node, right? So therefore, now we can start. So if I say V2 is, no, let me not start there. So you can see that this 15 source is connected between this node and that node, right? So therefore, if you do a KVL in this loop, that means that the sum of these three is equal to, so the one thing that you must remember, you mustn't forget the polarities, right? So first of all, here are the directions of our loops, right? We'll call this loop 1, loop 2. Why doesn't the 2 want to draw? 2, and loop 3, right? So when we're looking at loop 2, right, we say that positive 15 minus V2 minus 10 is equal to 0 via KVL. This gives you a value for V2 is equal to positive 5, right? And then in loop number 1, you've got negative 20, because we're starting here, we're going up like that. Negative 20 minus 25 plus 10 plus V1 is equal to 0. So therefore, our V1 is equal to negative 35. No, actually positive 35. Positive 35. Because we're taking the sum of this to that side. And then for our third loop, we have negative V1 plus V2 plus V3 is equal to 0. So therefore, V3 is equal to V1 minus V2, which is 30. And yeah, that's that answer. Pretty simple. And for 213, they say find the current I1, I2, I3, and I4. Okay? Okay, let's start at this branch, right? So we've got a 2 amp coming in there. So we've got a 2 amp coming in there. You have I4 there. And you've got 4 amp coming in there, right? So therefore, so the sum of current flowing in is 2 amps is equal to the sum of currents flowing out, I4 plus 4. So this gives us I4 is equal to minus 2 amps, right? That is what I4 is equal to. And then when we look at our node here, right, we've got I4 coming in, and we have I3 flowing out, and we have a 7 amp flowing in, right? So therefore, the current flowing in is 7 plus I4 is equal to the current flowing out, I3. This gives us I3 is equal to 5 amps. Okay? And then the other node we're going to look at is here. Alright? So this one is a little bit weirder because you've got I2 flowing out there. Then you've got a 3 amp flowing out there. And you've got a 7 amp flowing out there, right? So therefore, I2 plus 7 plus 3 is equal, plus 3 is equal to 0. This gives us a value of I2 is equal to negative 10 amps. Okay? Must really fix my stylus. And then the last node is this node going on there, right? So for that node, you've got I1 flowing in. You got I2 flowing in. And you have a 2 amp flowing out. Right? So therefore, I1 plus I2, which are the ones flowing in, 2. That is equal to the 2 amps flowing out. So therefore, your I1 will be equal to 12 amps. this is the next question we have. Given the circuit in figure 2.78, use KVL to find the voltages V1 to V4. Okay, so we'll say that's loop 1, loop 2, loop 3, and loop 4. So okay, we'll start in loop 4. Right, so in loop 4 we have negative V4 plus 2 plus 5 is equal to 0. This gives us that V4 is equal to 7 volts. And then in loop 3 we have V3 plus V4 plus 4 is equal to 0. This gives us a value of V3 is equal to negative 11. Right? And then when we go to loop 1, we have negative V3 minus 3 plus V1 is equal to 0. This gives a value of V1 is equal to minus 8. And then in loop 2, we have negative V2 minus 2 minus V1 is equal to 0. This gives us a value of V2 is equal to 6 volts. In this one, they say calculate V and Ix in the circuit. Okay. So this is loop 1. And this is loop 2. Oh, I must get a new stylus. Come on, give me a 2. Give me a 2. Okay. So in loop 1, we are going to apply our KVL, right? So negative 12 volts. What the hell? Negative 12 volts. Eraser still on. Negative 12 volts plus V plus 2 is equal to 0. So therefore, our V is equal to 10. And then now for Ix. So in our second loop, we have 8 volts plus 3Ix minus 2 is equal to 0, right? So this gives us Ix is equal to negative 6 over 3, which is negative 2 amps. So yeah, I hope this is an example of the dependent source. So if you were to be asked what is the voltage across the dependent source, it would be 3 multiplied by negative 2, which is negative 6 volts, right? So therefore Ix produces negative 6 volts. Here's another one. Determine I/O in the circuit. Okay. So you've got one loop. Very nice. So negative 36 plus 4 IO. Why am I using 4 IO? V is equal to RI, right? And I, as you can see, the current in the circuit is IO. So therefore, the voltage across here is 4, the resistance 4, multiplied by I. That's why you got negative 6 plus 4 times IO plus 5 IO is equal to 0. So therefore, you get IO is equal to 36 over 9, which is 6, right? 6, 9, 18, 27, 36. 6 amperes. Oh, my bad. Not 6, it's 4. 9, 18, 27, 36. Yeah, that's a 4. For the network in figure 289, find the current, voltage, and power associated with the 20 kilo ohm resistor. 20 kilo ohm is this guy right there. And this dependent source is dependent on this voltage there. So VO is equal to 10K multiplied by 5M. Why? Our classic V is equal to RI. That makes it 50 volts because the kilo cancels with the milli and you get a 50 volts, right? So therefore now you've got a current source here, which is 0.01 multiplied by 50. It's a 0.5 amp current source with a 5K here and a 20K there, right? So they say current, voltage, and power, right? So first of all, your current I is equal to 5 over 5 plus 20 multiplied by our 0.5. So 5 over 25 multiplied by 0.5. That is equal to 0.1 amps or 100 milliamps. And to find the voltage, V is equal to RI, which is equal to it's equal to 100 M multiplied by 20K, which gives you 20 volts, right? So that is your answer. And obviously, P is equal to VI. So when you've got 0.1 multiplied by 20, that gives you 2 watts of power. Oh, okay. I actually made a little bit of a mistake here. Instead of 20, this should have not been 20. This should have been 2000 volts, which is 2 kilovolts. Because those two cancel out, and that's 2000, so that's 2 kilovolts. So therefore, this is 2K, so that gives you 200 watts. So for this one, they say determine I1 to I5. Okie dokie. So when somebody looks at this, they would have been tempted to say that I1 is equal to 40 over 3 plus 4. That is wrong. Why is it wrong? Because the resistance between this node and this node is not just this 4 ohm, but it's 4 in parallel with 1 in parallel with 2, right? So then obviously we need to start by finding R equivalent, right? So therefore we say 1 over R equivalent is equal to 1 over our 4 plus 1 over our 1 plus 1 over 2, which is, getting out the calculator, 1 over 4 plus 1 over 2. So our R equivalent is 7 over 4. 1 over R equivalent. So therefore, R equivalent is equal to 4 over 7, right? So now we can find out what I1 is. I1 is equal to 40 divided by 3 plus 4 over 7. 40 divided by 3 plus 4 over 7, which is equal to 11.2 amps. Okay? So that was I1 done. Okay. So now to find I2, I3, and I4. Okay. So now we need to find the equivalent resistance there. We'll just call this REQ1. And then for REQ2, we've got 1 times 2 over 1 plus 2, which is just 2 over 3, right? So therefore, now we can say that I2 is equal to 2 over 3 divided by 2 over 3 plus 4 multiplied by I1, which gives us 2 over 3 divided by 2 over 3 plus 4, which gives us, oh no, I must multiply by 11.2, a value of 1.6 amps, right? That's I2. And I3, you could do the same thing we did here, or you could just say I3 is I1 minus I2, which is 11.2 minus 1.6. 11.2 minus 1.6, that gives us a value of 9.6 amps. Okay, and then now to find the I4 and I5, right? So to find I4 and I5, we can just say I4 is equal to 2 over 1 plus 2 multiplied by our I3, which gives us 2 over 3 multiplied by 9.6. That's equal to a nice 6.4 amps. That's I4. And I5 is equal to I3 minus I4, which is 3.2 amps. Yep. And that is that one. Pretty long question.